Hello guys, Cyprien here, and in this lesson we'll talk about some basic principle of the symbol language used in OnScale Analyst scripting. So this very short video, well, I will try to keep it short and right to the point, will be intended for people who do not necessarily have any background in scripting or in writing code. So I'll try to make it very simple for you to understand. And we'll talk about what is symbol and how you can use it to build some very simple code. So we'll talk about loops, we'll talk about procedures, we'll talk about how to print more information into your console or into files. So though everything I'll be talking here is very important information if you're serious about learning how to write some scripting into OnScale Analyst. So let's start with what is actually symbol. So it's probably the first time you hear about symbol language, and it was also the first time for me because this is a language that's basically have been invented by the engineers who worked for OnScale company a long time ago. So this language was invented 30 plus years ago when there basically was a need for a script language, but there was none at the time. So at the time, people were still using FORTRAN to do some coding because FORTRAN is very useful for mathematical and scientific calculation. But the big disadvantage of FORTRAN is that whenever you want to use a FORTRAN code, you have to compile it first. So it makes it very, let's say, not that intuitive to use if you are in a very simple code and you don't want to make some things very complicated. So the symbol language is basically some kind of scripting based on FORTRAN. So you can understand it as some kind of FORTRAN script. And the advantage is that it doesn't need to be compiled. So the code you see on the right is symbol language code. And this is the code used into OnScale Analyst. So this code is, well, you see the basic way is the following. First, you write a main command, which is basically written in blue. So like geom, mat, site, graph, all this function that I've talked into the previous videos of this series that you'll find in this playlist. And then you have some subcommands which are basically going under one of those commands. So if you are working with the geom command, you'll find out that the geom command has some subcommand called xcrd, like x coordinate, which will help you to define the coordinates of the geom command. So blue one are called commands, green one are called subcommands, and then you have comments. So the one in profound green color like that are comments. So if the comments come after an instruction, it's you put a small backslash and a star, and this becomes a comment. So this is not interpreted by the symbol interpreter. If you want to put it at the start of the line, you put a little C, a space, and you write your comment. So I'll show you right after how this looks. Okay, so let's go to the next slide. So now that you know more or less what is a symbol language, maybe what you are wondering is, what can I actually do with the symbol language, right? Because it's a language, so you can do a lot of things. Most of the things that, let's say, a simple scripting language can do, you can do it also with symbol. So for example, you can define variables for inputs to the comments. You can define equations with those variables. You can define some math functions. So it has integrated built-in time functions for sinus, cosinus, and a lot of other kinds of mathematical functions which are required. You have some loops, if statements, procedures, which are a bit like functions, so we'll talk about that. You have I/O functions. By that I mean read write into files, and we have various kind of functions which help you to write variables in memory. Or we also have some function which can execute external software. So you can actually embed some call to external software within the symbol code. Very useful. So let me give you a quick show off of the command reference, because this is very useful to know about that. So this is the example that I'll be showing to you right after. But first, let me show you the command reference. So if you click on any command in blue, right click, and you'll have a show help for term. Or you can go to the help and click on command reference. So both are working. And this should open either in a browser if you or directly within OnScale. So it depends what you have set up in the settings. I find it more convenient to open it in the browser, so you can change in the settings if you want to open it in the browser. Anyway, so this is the command reference, and you have a part called symbol commands. So it's also here in the menu. So if you click on that, you'll see various symbol commands available, and you have some do and go to, if else, proc, and a lot of type of sim-based functions. So I'll talk about some of the major interesting ones right after. So this is just to show you that you have very detailed explanation about what each of those commands do if you're interested to learn more in details about those. Okay, let's close that for now. Let's go back to the PPT. Let's talk now about a few rules to define symbol variables, which are important. And I'll show you a few examples. So the first thing you need to know is that numerical variables are implicitly typed according to default FORTRAN convention. In FORTRAN, you have this kind of implicit declaration of variables that can be used, and it depends on some variables, or sometimes you have to define manually the type of variables you want to define. Well, you know, in all compiled code, the variable type you use is kind of a big problem. So in symbol is not that difficult if you know how it works. And the way it works is that basically integer numerical variables must have names which begin with the letters which are included in this I to N array. So if the name of your variable you use is between I and N in the alphabetical order, then this will be integer. So N will be an integer, I will be an integer, and anything in between. So IGK, etc. IGK, LMNO, LMN, all of those will be integers. Now, if you want real numerical variables, then you have to choose a name which is between AH or OZ. So basically all the other letters. So, for example, sim radius equal to 35.97. This will be a real because you have a point, but you have to give it a name which has a first letter included in A to H or O to Z. If you do some mistake, you use a name starting by I, N, or something like that, then your variable here will become 0. So you can look at this small example. Here I have a variable called inner rad, and it starts with I. So I want this value to be 4.7 power minus 3, but actually what the interpreter reads is 0 here. It rounds to the nearest integer. So be careful about that. This is a rule you really need to know about. Now, there are a few more things to know. Variables are case sensitive, so it's not the same to have a little b or a bit, say a large B, a capital B or a small b. will be different. So you have to be careful about that. Now, if you want to define a variable, you just write semp plus the name of the variable with a space in between. And if you want to use a variable, which means in another expression or in an equation, you add a $sign before the name. And this is also a very important rule. All symbol entries must have some blanks in between. So you need to leave some space in between each of your expressions. So it's not that intuitive. So for example, you have 2 multiplied by a variable called $pi multiplied by $radius, and you have to leave a space in between each of those. Otherwise, this will not be interpreted correctly. So generally, you have some notice when you don't leave a space, it will tell you, please leave a space. So you should be aware about that. But in case, sometimes you get problems because of this. Okay, and now that we know about these rules, let's switch to OnScale and let's try that. So I opened a new Analyst window and I have written some comments. So you see it's in green, and this is a comment because there is a little C before that. Now let's try to declare some variables. So let's start with an integer. So semp to declare variable, I'll call I equal, and let's give it a value of 1. Now I will try to declare a real value. So let's call it semp radius, for example. Radius equal, and I think the example was 35.97. And that's it. So, okay, now I have 2 variables. Let's save this and let's run that. So you can use run solver if you have a local license, or you can use preview model. This will work also. Don't forget the term at the end to pause the script. Okay. Okay, and this code has been interpreted and those variables have been assigned. And you can see that as soon as this is read and this starts to run, the variables window here starts to be filled with the name of those variables that are defined. And this is extremely useful in OnScale to know about this, because in a real study you have a lot of variables which are sometimes defined with a loop and all that. So here in this variable window you see all the variables defined inside your model. So you know exactly which value they have at the present moment. So the I is an integer and its value is 1, and the radius is a float, so it means it's a real, and the value is exactly what I defined it. Now let's suppose that I don't know about this rule, and let's stop the preview. Let's give it a try. What would I have if I started that with an I, for example, I radius. By the way, you have now a notice, so it's actually easy because it tells you that you must have to use integer value for these variable because start with I. But let's say that I didn't have that and I still want to try. Preview. And now basically you see that this has been defined as an integer and the value is equal to 35. So it has basically rounded the real value. So don't forget about this rule, right? Now let's try an equation. So let's do, I don't know, semp calc, let's call result. Let's say result variable, and this will be equal to I multiplied by radius. Okay, and now it also tells me that I want to use those variables, but I forgot the $sign. So whenever you want to use some variables, use the $sign to call those variables that you have defined previously. Let's run this, and you see now that I have the result variable, which is basically equal to the product. So this is equal to 1. So basically this is, let's put that equal to 2. Let's try again. Okay, it works. So it has multiplied. So note that you need to leave a blank space in between these variables. If you have no space like that, you'll get a message so that you need to leave a space. And that's it. So let's go back to the next part of the presentation. So that's what I was telling you. Once you use those variables and you compute, you'll see the result into the variables manager. You have also the data manager, which is also useful to see the computed variables. So once you run a simulation, all your simulated data arrays are stored into the data manager. Now let's talk about something else which is also very useful, which is how do you write a message to the console. Sometimes you want to not only to run variables and numerical expressions, but you want also to write some text. So basically to declare something or to show some text to the console, or maybe you want to show it into a text file. So we'll have a look at how to do that. So you have the basic syntax is actually very simple. You use symb, and then you have this sign and message MSG basically, and then you have a certain number. So the number here represents the number of lines of text you want to print out. So here, if it's 1, it will read only the next lines. And then it will print it to the console. If you have 2, it will read 2 lines. And note that you can print some variables. So you can freely include some variables within the text like that, and this will be interpreted to the console. So let's try. Let's try writing a message to the console. So let's put a comment, writing a message. So the syntax is very easy. Symb, hash, MSG, then the number of line of my message. And let's start with a simple hello world to see what I'm getting. Save that. Let's use this preview function. And you see that here in the console, I'm getting the hello world. So it means it works. I'm printing to this file this line. Now, if I wanted to put some variables in it, I could do that as well. So let's put some. Okay, this is my radius. Okay, and here I'll just basically put my radius variable. So don't forget the $sign here. And if I preview that, you see that it appears also in the console, so it works. Now the last thing to know is that I can add several lines. So if I put message 2 like this, I can put 2 lines, and this is the result. Okay, I know it doesn't mean anything, but this is just to show you the message function, right? Result. And you see that my 2 lines are printed. So what would happen if I had only I have 2 lines, but I have only message 1? So basically I forgot to change this number. Just to show you, of course, you'll get an error. So you'll get an invalid input because it just look at the first line, and then it believes that this is a symbol common when this is not. So you get some problem here. So don't forget to change this to 2. Okay, so it's nice to print those messages in the console, but what if I want those messages printed into a file? So it's actually pretty easy to do. The only thing you have to do is to add this greater than sign right after the number, the message number, and you put this greater than sign and the name of your file you want it to be saved in. And if you put 2 signs like this will append to the text to an existing file. So just 1 sign will create a new text file and overwrite whatever text file already existed before. But if you put 2, this will actually append to it. So let's try that. So this is the message I have written to the console previously. And now let's put that to a file. So let's try. Let's put a greater sign. And you see that you have description of what this can actually do. So you can read this. You have other options as well. So if I type like this sign and I print the name, so let's call it, I don't know, my file.txt. You can give it the extension you want. It can be CSV, it can be anything. Okay, now save that. Let's compute this. So this doesn't appear anymore to the console. But if you look at the file explorer, you have now a myfile.txt file. So let me open this. And you see that what was printed to the console is now written to this file. So if I want to, let's say, add something more to this file afterwards, let's say I'll add, this is an append, right? Let's put a blank in between this. So this will be 2 lines again. And this I want to append, so I'm using to sign like this. And let's run this again. Let's open this text file to see what I have. And you see that it works. I have the first line and I have the appended text afterwards. So you understand that you can actually do some kind of small reports using this way. So you could, so I didn't talk yet in this series about the review, which is kind of a post-processing script. But if you want, you can write a review script, which will basically post-process some of the variables, some of the result of your model, and print that to a text file, like a report for your model, which is pretty cool. Okay, let's back to the presentation. I have a few more interesting things to talk about. Let's talk briefly about loops and other kind of function to control the flow in your script. So a loop is actually pretty easy to define. You start with a do, then you give a name to your loop. So it can be anything. It can be loop 1, loop 2, loop 3, or any name you want. Then you give it an integer variable so here I call it I, but it can be anything, which is an integer. So remember the rule to define a variable. And then the start of the variable, the end of the variable, and the last is the increment. So if the last is 1, the I integer will go from 1 to 10, 1 by 1. If this is 2, it will go to 2 by 2, etc. And then in between, you put whatever you want. And at the end, you put an end with a $sign. So don't forget the dollar. And then the name of the loop. So you close the loop like this. So this is the way a loop is defined. So let's try it out. So you remember that I had this code. So let's remove this to put it to a file. Let's simplify a bit this. And let's say that this message, well, I want it printed 3 times. So I'll put a loop around it. Don't ask me why I want this, but I'm just interested to do this. And let's put a message 3, so it will print a blank as well. So if you remember do, let's call it loop 1. Give it a name of a variable, so it'd be 1. Going from 1 to, let's print it 5 times, and with an increment of 1. And at the end, I need that end $sign, and I need the name of the loop, loop 1. Okay, so let's try it out. And you see it works in the console. I'm getting 5 times whatever is inside the loop. So this is how you create some loops. And you can have some embedded loops. So if inside this loop, I have a do loop 2, so give it another name, and I call it j, for example, going also from 1 to 5 with one increment. I have to close this loop before the other one, loop 2, right? Now this will be printed 25 times. So let's stop that and let's print it. And let's have a look at how many times this is printed. Yeah, a bunch of times. Now, well, maybe instead of putting this, I can put the name of my increment. So my I will be this, my j will be this. Let's print that and see what I'm getting. So you can see that this is how the loop is embedded. So it counts first I is equal to 1, then j to 1, then basically j goes to 2, 3, 4, 5, and the I goes to 2, and it starts back until both variables are equal to 5. So this is an embedded loop. Let's go back to the presentation. Now let's have a look at another type of conditional flow, if, else, if. So classic type of instruction when you're doing coding. So the syntax is like if, then you put some parentheses, and in between the parentheses you have a comparison between two numbers. So the number 1 here is called datum1, and the number 2 is called datum2, and they can be either numeric or character data. And in between, this OP is called OP here, but it actually has to be one of the 6 conditional operators. So they are the same than the one used in FORTRAN, so same than the FORTRAN convention. So AQ means equal, NE non-equal, LT lower than, LE lower and equal, JT and JE are respectively greater than and greater and equal. So you can do some comparison using those. So if I can compare, for example, a value, and then I can use Elseif, else, and I have to use then after the parentheses to execute those instructions. So let's try. This file starts to become a bit overloaded. Well, not really, but anyway, let's open a new file. Okay. Okay. And because I like to put things together, I can move that to the split view to have it on the right. So that's a pretty cool function. If you didn't know we have that, there you have it. You can view two bits of code here. So let's have a look at the if else. So let's create first a variable. So variable will be simp I, and it will be equal to 1. And now if else condition. So if you remember, if, then parentheses, always leave a blank between each of those. If, and to use the I variable, I have to add a $sign. If else is greater than 2, then execute the instruction here. Else it will do the instruction here, and at the end I have to add an and if. So let's say that the instruction is a message simp msg1, which will basically tell me I is greater than 2, and for the else condition, I'll basically put then I is lower than 2. All right, very basic stuff. So let's execute that and see what I have. Okay, and of course my I is 1, so I get the message that I is lower than 2. So it executes this loop. Now if I change my I to 2 and I run this, now it tells me that okay, greater than, yeah, I have. So now it's greater but not equal. So it's equal to 2, so it's still, it doesn't equal this. So let's put it equal to 3. And now it tells me I is greater than 2. If I want the equality, remember it should be JE than 2. Greater or equal. Okay, works. And that is the if-else loop. Let's talk now about procedures. So this is extremely useful part of this video. You have absolutely to know about procedure because this is used all the time in all the analysis script. You will find the word proc, so you have to understand how it works. And the concept is actually very simple. It's basically like a function. So it's like a custom function that you define and that you can execute as much as you need. So the basic syntax is like instead of using function as a keyword, you use proc, like procedure. Then you write the name of the procedure, so you can give it any name you want. And you write the keyword save to save this into memory. And you finish this procedure with and dollar, don't forget the dollar, and proc. And you put whatever inside this procedure. So this code inside will be executed every time you call the procedure. And you can execute the procedure by using proc, the name of the procedure. And if you put a number afterwards, it will execute this procedure a certain number of time. You can use variables inside procedures, but there is no local variables concept in Symbol. So you cannot define a variable which is only available within one specific procedure. All variables are global. So, well, I don't like this very much, but you know, this is the way this kind of code has been written. So it's a bit like FORTRAN is like that. So global variables are very annoying. But anyway, this is how it works. So you can define variables, but you have to be aware that those variables will be available globally in your script. So let's give it a try. So let's call that. Let's wipe out the content of this script here. And let's call it procedure. Right, so let me define a procedure, proc. Let's give it a name. So I'll call it warm greetings. Save and end dollar proc. So inside I can put whatever I want. So send message 1. Hello to OnScale. Right. Okay, and now I have my procedure. So, and if we want to execute this procedure, so proc, then I use the name of the procedure that I already saved here before, and I can execute it a certain number of times, like 5 times. Let's put the term at the end. Let's run that. And you see that in the console, this procedure is executed a certain number of times. So procedure can be used like loops as well. If you, for example, you define a variable, let's say you define a variable here, semb I equal to 0. Let's say that in my message, I want this, say this is the step I of calculation. And let's say that every time at the end of the procedure, I'm updating this variable. So remember, you cannot do I equal to $i plus 1. doesn't work like this, or you cannot write either $I, you have to write simp every time. So simp I equal $I plus 1. That's the way to update the variables. And now, if I run it 5 times, well, let's say I'll do like this. And let's say this is equal to 1 when I start. If I run again the code, you see that this will print out and increment the variable at the same time. So it's a bit like a loop, but not exactly a loop. And this procedure is used in OnScale to compute every step of the simulation. So I'll talk about that after, but there is a keyword in OnScale called exec, and there is a number going after that, like exec1, and this basically means execute one time step of my simulation. And if, let's say, you execute 10 time step and you put that into a proc like this, and then you execute the proc 5 times, it will execute in total 50 time steps of your simulation. And you can use this proc to do some other things at every time this is computed, like showing a graphical plot of what is going on at this step of the simulation. So that's why it's pretty useful. We'll talk about that later when I show you how to use the execution loop. So that's why you need to know about procedures. Know that when you define a variable, you can also use mathematical operators. So you could write the name of your variable equal and use a certain expression. And this expression can be any of the following mathematical operators. It can be cosinus, sinus, tangent, exponential, logarithm, or absolute, SQRT for the square root, mean, maximum, all of that can be used. So if you do cosinus 0.3, you'll get the result of this expression saved into this variable. And you can use parentheses to control the sequence in which the expression are evaluated, like you would do for any kind of mathematical type of equation. The last thing I want to talk about in this video is about the symbol built-in function. It's important to understand all these kind of functions that you have already into the code, which are actually very useful. And they are written like this: simp, then you have some kind of keywords. So usually it's get, but you have also some other keywords. And the value you have into parentheses here is the result, it's the output. And the name which is right after the parentheses is a keyword name for the function. And whatever you have after are input parameters. So it kind of works backwards. So this function charlen, what this function is doing is that it's actually taking the string here, you give it as an input, it calculates the length of this string and it returns it into the iLength variable. So and then it creates a symbol variable with this iLength, which is the length of this string. You have many functions available. So the second one, for example, iWallClock, will give you certain number of the time your script is taking to execute. So if you want to measure the time in your script, you can use this. This function, for example, CLS node, is very useful because you give it some coordinate x, y, z. So you can give it a certain area of your model, and it will return to you the coordinates of the closest nodes in your model. So it will give you II, ij, and ik, which are the coordinate of the closest node from the coordinate points that you are giving it to. So pretty useful if you want to measure some precise area of your model, and you know only the coordinate in meters or in millimeter, but you don't know what node it is located nearby. So you can use this. So how to know all the functions available? Well, same thing than before. Go in the documentation. So if I go into OnScale and I open the documentation, command reference, and I go into symbol commands, you see you have sim here, and go to sim get, and here you have function names to do a bunch of things. So time information, return data manager from arrays, coordinate data, elemental data, nodal data, material information, graphical information, etc. So you can have a close look at each of those. For example, material, let's look at material information. You have, for example, mat bound. So what this function does is that it returns a spatial coordinates or IGK indices that bound a specific material that has been assigned to continuum elements. So it can be useful in some cases. So basically you have all those functions. And sometimes you want to do something, you have to know that they are built-in functions to do this. So one function that is useful I found is, for example, simp submit, which will allow you to submit an external process. So I'll show you afterwards what it means, but it's pretty cool. It allows you to do some cool things. So let me give you some quick example. So this is the previous exercise that I did with the embedded loop. Let's try to use one of those functions, let's say within the loop. So let's use this I will clock function and see how it works. So this I will clock will automatically return 4 parameters. So the first one is the total number of seconds, then you have number of seconds, or you can have it converted into minutes, hour, or days. So this loop here is going very fast to calculate on my processor because I have a very fast computer. So to increase a bit the difficulty so that it takes more time to calculate, let's change that to 2000. And here, let's print out the variable, let's call it time in second. And this will be, it's written in blue because this is also the name of a command, but actually this is just text. And like that, let's write this variable here. And let's see what I have if I execute this code. Now you see that while it calculates in live, the time in second is incremented. And now it's over. So it took 3 seconds to calculate. So not bad for like 10,000 increments, because 2,000 multiplied by 5, 10,000 in total. And you see that this variable here, num second total, the last value of this is 3. So this is the total number of seconds it took to run this this script. That's how you use basic functions like it. Now, to finish this video and also to thank you for watching all this in this entirety, I'd like to show you something really cool that I like very much. So this is a script, the basic basic script from the tutorials. But what I did is that I added some of the function I was showing you in the video to generate a report within the script. So what I did is that, let's say, so here, for example, I added this simp message and I'm saving that to an org file. And if I go down at certain portion of the location, I'm just appending some text to my report. So this will be a report in text format called org, which is an, if you don't know, org mode into Emacs. It's pretty cool stuff. So you can have a look at Google org mode and what it is. So basically, I did all that. And whenever I run this model, it generates for me a report in text format. And I can include images, I can include what I want in it, and even tables like this. And at the end of the code, what I'm doing is that I use this simp submit function, and I use pendoc, which is an external software. It's pretty cool and allow you to transform this report.org into any kind of other format. So you can generate a docx, like a Word, a PDF, PPT, any kind of format can be generated. So you're basically generating a report, and and transforming that into a document. Let me show you what it looks like in PDF. So in PDF, it looks like that. So basically, you are exporting your picture. You can add some caption. You can add some tables, variables, and everything like that. And it's basically exported in LaTeX and then converted into PDF using a Pandoc. So pretty cool. If you want to download, you have to download and install Pandoc. So if you want it to work, so go to the Pandoc website, which is an universal document converter, install it on your Windows machine, and you'll be able to use this code. So that was just something to give you some thoughts at the end of this video, so it can be useful. So thank you very much for watching this video, and I really hope this was useful, and that if it was, please give it a like and let me know in the comment. Thank you very much.